So now sometimes we're going to have a derivative that we have to take of something that involves a combination rules. And you can see there's actually a couple things going on right here. Right away, you definitely see that there is a chain rule kind of expression, but it's part of a product. And so what we really have to do is we have to handle the product rule, the outermost thing that's happening first, and then get to our chain rule inside of that. So if we want to treat this as our product rule, right? Whenever we said if we had a function that was equal to two different ones, and we're going to call this f of x here, and we'll call this one g of x, right? Our derivative for our product y prime is going to equal the derivative of the first function times the second function, leaving the second function alone, added to the first function times the derivative of the second. So g prime of x. All right, so what did we say each of these things were? Well, in our case, y prime is the derivative of f of x, right? So it would be the derivative with respect to x of 2x squared, and that's times our second function, which we don't really have to do anything with. That's 3 minus x squared to the fifth, added to, and then we're going to have to take our first function. So our first function, f of x, we said that was 2x squared. But now we're going to have to take that times the derivative with respect to x of 3 minus x squared to the fifth. All right. So right over here, this one isn't too bad, right? We can take the derivative of 2x squared fairly easily. Y prime in this first term is going to be 4x, right? 2 times 2x, 4x times the quantity 3 minus x squared raised to the fifth. Plus, and then our second term, we're going to take 2x squared, but this time, right, we have one of these chain rule issues, which means that we're going to have an inner and outer function. And so I'm going to do a dangerous thing here. I'm not going to replace with u and u prime because I really kind of know what that is. If I have to on the side, I might take it out and write, okay, let's let u be 3 minus x squared, so that I want to take u to the fifth and use my chain rule for that. But I know what's going to happen. What's going to happen is that I'm going to have to take this power 5 times u, which is 3 minus x squared raised to the fourth power, and that's going to be have to be multiplied by u prime. And u prime, we know, is going to be negative 2x, 0 minus 2x. So we're going to have times negative 2x here in this quantity. That's our derivative. We've just taken the derivative. The rest of this is trying to simplify everything down. And this is now where we're going to have to be savvy to some of our factoring tricks. And I don't know how well you remember factoring tricks, but let me show you a few. All right, we've got 4x times 3 minus x squared to the fifth. And when I put all this together, this is actually going to become 2 times 5 times 10. And it's going to become negative because we've got a negative factor right here. So negative 20 x to the third, when we take x squared and multiply it by x, times 3 minus x squared raised to the fourth. Okay, now here's our tricky part. Okay, it's tricky because we have a couple different things that we can do to factor and simplify this expression a little bit more. We're not going to expand anything to the fourth. Forget it. If you want to spend your time expanding things to the fifth power and the fourth power, you go right ahead. But that's going to be a big old waste of time as far as I'm concerned. Look, we've got some common factors here that we can factor out. I will point out to you a couple of them. For example, 4 and x are both factors of 20x cubed, right? This is the same thing as 4x times 5x squared, right? And of course, this is 4x times 1. So 4x is now a common factor, right? So we can factor that out. So I'll put that out front here. Y prime in its factored form is going to be 4x times. And what will be left over? Well, we're going to have 3x squared, 3 minus x squared to the fifth, and 3 minus x squared to the fourth. Now that's kind of interesting because now we actually do have another common factor. And let's mark this one. 3 minus x squared to the fifth and 3 minus x squared to the fourth both share a common factor of 3 minus x squared to the fourth. If you don't see it right here, this is the same thing as 3 minus x squared times 3 minus x squared to the fourth. And here's 3 minus x squared to the fourth right here. So that can come out as a common factor. And we're going to have the quantity 3 minus x squared to the fourth. And now we would ask, well, what's left over? All right, well, what's left over right here, we've just used up this factor and this factor. We just factored out 4x, and lo and behold, we have this 3 minus x squared left from our first term right here, minus, and let's see, in this case, 5x squared. So if I simplify this down completely, I actually end up with y equals 4x times 3 minus x squared times 3 minus 6x squared, which is kind of interesting because, look, we've got another common factor of 3 between these two terms. So I'm going to change this one more time and say, well, y prime then, in its most simplified and factored form, could be written as 4 times 3, 12, times x times 3 minus x squared. This is to the fourth still. I neglected to put that up there. 3 minus x squared to the fourth. And 1 minus 2x squared here when we factor out the 3. Put it in front. There it is. This is the simplified version I would want to see on my paper.